Thanks for joining me. We're going to do science, and we're still in Unit 2, and today we're in Lesson 2, Ocean Waves, and we can all kind of daydream about the times we've been at the ocean and how wonderful it is. There's just something awesome about the ocean, and so kind of fun chapter to read. And so if you'll read with me, let's start on page 68. What are some properties of a wave? Have you ever seen a surfer riding waves? Or have you jumped into a pool and made waves? A wave is any disturbance that transfers energy through matter or empty space. An ocean wave is a disturbance that transfers energy through ocean water. Size. Waves are made up of two main parts, crests and troughs. A crest is the highest point of a wave. A trough is the lowest point of a wave. The top of a rise on a roller coaster track is similar to the crest of a wave. The bottom of a dip in the track resembles the trough of a wave. The bottom of a dip in the track resembles the trough of a wave. The distance between two adjacent wave crests or wave troughs is wavelength. Wave amplitude is half the distance between the crest and the trough. The diagram below shows the parts of a wave. So look here, it says you see the diagram of the wave, and the crest is the very tip top. It's the highest point that the wave reaches. And the wavelength is the distance between the two crests, the crest of one wave followed by the crest of the other. And a trough, that's the lowest point. And then the amplitude is half the distance between the crest and the trough. So the amplitude is that center point. Okay, let's go to page 69. Frequency and wave period. Wavelength and amplitude are not the only properties used to describe a wave. Waves also vary in frequency and wave period. These two properties are related but different. Frequency is the number of waves produced in a given amount of time. You can measure the frequency of an ocean wave by counting how many waves pass a fixed point in a certain amount of time. If you see 5 waves pass the point in 10 seconds, then the frequency is 5 waves per 10 seconds, or 0.5 waves per second. Wave period, in contrast, is a measurement of how much time it takes for a wave to pass the fixed point. In other words, it is the inverse of frequency. Frequency is measured in waves per time, while wave period is measured in time per wave. Wave speed. Waves come in many different sizes and travel at different speeds. Wave speed is how fast a wave travels. To calculate wave speed, you can multiply the wave's wavelength by its frequency as shown below. For any given wave, an increase in either the frequency of the wave or the wavelength will cause an increase in wave speed. So wave speed, V, equals wavelength times frequency, and wave speed is measured in distance per time. Okay, let's turn the page and we'll keep reading. We'll come back to that again, but not right now. Surf's Up, page 70. What causes ocean waves? Waves carry energy. Ocean waves are a type of wave known as a mechanical wave. Mechanical waves carry energy through matter, such as water. Ocean waves form when energy is transferred from a source such as wind to the ocean. Wind. Most ocean waves form when energy in the atmosphere is transferred to the ocean's surface. Wind blows across the water surface and transfers energy to the water. The energy is then carried by the wave, usually all the way to the ocean shore. Have you ever wondered why ocean waves are different sizes? When wind begins to blow over water, small waves or ripples form. If the wind keeps blowing, more energy is transferred to the ripples. They grow into larger waves, and the longer the wind blows in the same direction across the water, the more energy is transferred from the wind to the water, and the larger the waves become. Page 71, earthquakes. Waves can also form from another source of energy. For example, underwater earthquakes can cause waves to form in the ocean. You could model this process by using a thin aluminum pan filled with water. Pushing up the bottom of the pan will cause water in the tray to move. Landslides. Underwater landslides can also displace water and cause waves. The ocean floor is made up of many features, including towering cliffs and the world's longest mountain chains. Landslides along these landforms push the surrounding water. The energy is then transferred outward, lifting the sea surface above the landslide. Volcanoes. Underwater volcanoes are another source of energy that can cause waves to form. Underwater volcanoes cause waves in a very similar way to how underwater earthquakes form waves. As the volcano erupts, the surrounding water is displaced, sending out a wave in all directions. Meteorites and asteroids. Meteorites and asteroids are rocky bodies from space that can collide with Earth. If a meteorite or asteroid lands in the ocean, it can displace enough water to cause large waves. If a large asteroid landed in the Atlantic Ocean, for example, the resulting wave could flood much of the east coast of the United States. Let's not put that on our bucket list for 2020. All right, doing the wave, page 72. What happens when a wave moves through the water? If you have watched ocean waves, you may have noticed that water seems to move across the ocean's surface. But this movement is only an illusion. Actually, waves don't move water. Instead, they transfer energy through water. Energy travels. As you learned on the previous page, most waves form when winds blow. Wind transfers energy to the water. As the energy moves through the water, so do the waves. But the water itself does not travel with the energy. So that's a big one to really stay focused on and to remember that it's not the water that's moving, but it's the energy moving through the water. Water rises and falls, but it still stays in the same place. Notice in the illustration that the floating seagull remains in approximately the same spot as the wave travels from left to right. The water and the seagull do not move with the wave, but only rise and fall in circular movements. This circular movement of water is generally the greatest at the ocean's surface. Wave energy affects surface water to a depth of about half a wavelength. Deeper water is not affected by the energy of the surface waves. And that's why like an undertow is deeper than the surface wave, and that's what actually will pull you out in a riptide. And so it's not like you can necessarily see it on the surface. There are some signs you can see along the beach, but the undertow is below that depth of the surface wave. So you can see an example with that little seagull. He's basically staying in the same spot, but moving in that circular pattern of riding the wave down, coming up with the wave, but basically staying in the same spot. All right, look at page 73, watts from waves. Every minute of every day, waves are crashing against the coastline of the U.S. That's a lot of energy being delivered directly to our doorstep. In fact, the Department of Energy estimates that about 7% of our electrical energy needs could be met by capturing wave energy along our coastlines. So, all right, turn the page to page 74. Totally turbulent. What happens when a wave reaches the shore? Ocean waves can transfer energy over very long distances. In fact, waves can travel thousands of miles across the ocean's surface. The energy is carried all the way to the shore. Energy decreases with depth. Why do waves crash on the shore? The figure below shows how changes in the depth of water cause waves to crash. When waves reach water shallower than 1/2 their wavelength, they begin to interact with the ocean floor. As waves touch the ocean floor, the waves transfer energy to the ocean floor. As a result, the water at the bottom of the wave slows down. Next, you see the wavelengths here are constant, but then as it gets closer to the shore, the wavelengths become shorter, and then the break forms. It breaks in shallow water. As water depth decreases, wave height increases because more water is forced between wave crests. The top of the wave travels faster than the bottom of the wave, which is dragging on the ocean floor. Eventually, gravity pulls the wave crests down and they crash onto the shore. These waves that crash onto shore are called breaks. It transfers energy to the shore. Most ocean waves reach the shore and transfer their energy to the beach environment. The energy of the wave and the angle at which the wave hits the shore determine how much energy is transferred. High energy waves can quickly erode beaches. Strong waves can even throw boulders and other debris up on the beach, particularly during storms. What is a tsunami? Surfers can go to Hawaii to catch some of the highest waves in the world, but even the best surfers would not be able to handle a tsunami. A tsunami is a series of waves that form when a large volume of ocean water is suddenly moved up or down. Like we said on the previous page, where if there's a significant amount of water displaced because of an earthquake on the ocean floor or a volcano or any earthquake along a landmass, that can displace a large amount of water, which then can form a tsunami. This movement can be caused by earthquakes, volcanic eruptions, landslides, or the impact of a meteorite or an asteroid. The illustration below shows how an underwater earthquake can cause a tsunami. Most tsunamis occur in the Pacific Ocean because many earthquakes occur in that region. Why? Because it's known as the Ring of Fire, so very volcanically active. When a tsunami approaches land, the waves slow down and get taller as they interact with the ocean floor. Tsunamis can reach more than 30 meters in height as they slam into the coast, destroying almost everything in their path. The huge volume of water that crashes onto shore then rushes back into the ocean. This powerful flow of water, called an undertow, can be just as destructive as the tsunami itself. And the one thing to know is that the first wave is not the only dangerous wave. Sometimes it's the second or third wave of the tsunami that is just as dangerous as the first. So be aware of that. And anytime you're in a situation where there might be a tsunami warning, you would want to move to higher ground. If you're out on the beach and you notice that a lot of water is being carried out to sea and there's a huge recession of water, then you would want to move to higher ground. A tsunami hit the Andaman Islands in 2004. I'll try to find some of that, but these are actual pictures of the footage of that wave coming and crashing in towards where all the people are. I don't know if it was a city. So now we have a lot of warning systems that will allow some of these smaller islands with less technology to get the information so more lives can be saved. All right, example 16, you can see there the displacement of water in the bottom of the figure where that red bullseye, the red rings are. That's the displacement, and then the energy moves up, creating that wave and the transfer of energy inland toward the shore. All right, What I would like you to do, your assignment, I would like you to look at numbers 1, 2, and 3 at the top of page 77. 1, 2, and 3, they have a diagram of a wave. And what I would like you to do is to create your own diagram using colored pencils. And it's not going to take that much time, but I'd like you to maybe make it stand out and be a little bit different. I'm thinking this will take you 10 minutes tops. 1, 2, and 3, I want you to label the parts of the wave. And then you can submit a picture of that at assignments.sestair.com. All right, I hope you have a great day. Talk to you later. Bye-bye.